Hello, this is part of my video series on basic statistics. Hello, this is part of my basic statistics video series to help your understanding on application of statistical knowledge and to prepare you for any statistical exam. So today we'll be looking at correlation, and to do this, would consider an example to do this. So we're given the data of hours worked and GPA of students, and we want to compute the Pearson correlation coefficient, the Spearman rank correlation coefficient, differentiate between the two methods, and conduct an hypothesis test at 5% significance level. So the formula to compute the Pearson correlation coefficient is given in as R equals to this. And then to do that, we'll then construct a computation table where we will then have the square of the x, the square of the y, and the product of the x and the y. So then we'll sum the total in each column to arrive at the totals. Then we'll substitute those values into the formula that we have, and the Spearman rank, the Pearson correlation coefficient, therefore will give us 0.057. And that's a very small percentage, right? For the Spearman rank correlation coefficient, we will therefore need to rank the x and the y's correspondingly, and according to rise, you can rank from descending order or ascending order, but you must be consistent for the two variables. So when we rank, we then compute the difference in the ranking and square. We sum the square and then substitute the value in the formula given here. That will give us the value 0.543, which is a little bit different from what we had earlier. So in comparison between the Pearson correlation coefficient and the Spearman correlation coefficient, we see that Pearson correlation coefficient measures linear relationship, whereby Spearman correlation coefficient measures monotonic relationship. And the Pearson uses actual numerical value, whereas the Spearman uses rank. Pearson correlation coefficient is sensitive to outliers, and Spearman is less sensitive to outliers as expected. It requires interval and ratio data, whereas the Spearman does not just is very suitable for ordinal data. As we would also see that the Pearson correlation coefficient approximates normality, and the Spearman is distribution free and non-parametric. So the next thing now for us is to test the significance of our claim of the hypothesis of the correlation. And so we set our hypothesis. The null hypothesis would be that there is correlation, but there is no correlation, that is rho is equal to 0. The alternative hypothesis, which is H1, would be that the correlation coefficient is not 0, and that means there is correlation. At 5% level of significance, we obtain the test statistics, which is given as t equals to r square root of n minus 2 over square root of 1 minus r squared. And by the time we substitute the values where the correlation coefficient we obtained earlier, that will give us that our test statistics is 0.114. At degrees of freedom of n minus 2, which is 4, and we obtain the critical value t 0.025, 4, that will give us 2.776 from the t table. And since our test statistics is less than the critical value 2.776, we reject the null hypothesis. In conclusion, our Pearson correlation coefficient indicates extremely weak positive linear relationship, whereas the Spearman correlation coefficient indicates moderate positive monotonic relationship. At 5% level of significance, there is no statistically significant linear relationship between the number of hours worked and student CGPA. I hope this video has been helpful. Thank you for listening. If it has been helpful, like, share, put your comments in the comment section, and subscribe to the channel for more videos. Thank you.